All right, so section 3 of chapter 2, translating between tables and expressions. I've got a couple examples there just to start off. I've got Cade and Maya on there, and no, they're not those ages. But when Cade is 9, here, Maya will be 11. When Cade is 10, Maya will be 12. When Cade is 11, Maya will be 13. When Cade is 12, Maya will be 14. Pretty simple. If Cade was 13, how old would Maya be? 15. Well, notice the very bottom one there is the letter N. If Cade was 30, how old would Maya be?
32.
So you just did a math problem in your head. How did you go from if Cade is 30, Maya is 32? What did you do?
Because there's 2 years apart.
They're 2 years apart. So to go from Cade to Maya, you added 2 every time, right? So I could write Maya's age as Cade plus 2. Would you agree? So now if Cade's age is N, what is Maya's age going to be?
50. M.
Nope.
No. Oh.
What did we do every time to Cade's age?
Oh. Add up.
We added 2. So this one here is like 9 plus 2, 10 plus 2, 11 plus 2, 12 plus 2. What would the next one be?
N plus 2.
N plus 2. So no matter what Cade's age is, we could always find Maya's. So N is our variable now. So you can pick any number. If Cade is 100, how old is Maya?
102.
If Cade is 52, how old is Maya?
54.
Okay, so you could put any number in there, that's your variable, and you could find Maya's age. So we just translated from a table to an expression. This lets us find any age of Maya if we know Cade's. Okay, another fairly simple one in a sense here. If you have 12 eggs, that equals 1 dozen. If you have 24 eggs, that equals 2 dozen. If you have 36 eggs, that equals 3 dozen. If you have 48 eggs, you have 4 dozen. It's a representation of a certain number of eggs.
You always times it by 12. Yeah, by 12. Yeah.
Okay, to go from dozen to eggs, you said times 12. What if I wanted to go from eggs to dozen? What do we do? What did you do? Did you do 12? You didn't do 12 times 12 to get to a dozen. How did you get from 12 to 1?
You divide 12.
We divided by 12. So when I first look at the table, I look at it and I say, all right, if I have 12, how do I get to 1? I can divide by 12, or I could subtract 11, right? Either way would work. And now I go on to my next one. If I take 24 and I subtract 11, do I get 2?
Yeah. No.
24 minus 11 is not 2. So minus 11 doesn't work for my expression here. What about 24 divided by 12? Does it work?
Yes.
I get 2. 36 divided by 12. Does it work?
Yes.
48 divided by 12. Does it work?
Yes.
So all of these are 12 divided by 12. 24 divided by 12. 36 divided by 12. 48 divided by 12. So now if I have a variable of e, what would my expression be?
Well, E divided by 12.
E divided by 12. So you're seeing, what do I do to go from the left column to get to the right column? And sometimes they'll be written vertically, and it'll be how do I go from the top to the bottom. Okay? So you're trying to figure out what expression works for every single one of those. All right? Okay, so now I should have changed this word. It probably should say, instead of formula, it should say expression. So let's change that to expression. Because we're actually not making a formula. A formula would have an equal sign. So So think about this one. Take a minute. Try to figure out how could you get from the position to the value every time. So if we did 1 times 2, we get to 2. How do we get to 3 now from there? How do we get to 3 from there? Plus 1. Let's try it on the next one. 2 times 2 gets us to what number?
4.
And then if we add 1, do we get to 5? What about 3 times 2 plus 1? Does that get us 7? So am I doing the same thing every time so far?
Yeah.
4 times 2 plus 1. Does that get us 9? 5 times 2 plus 1. Does that get us 11? So if we want to do n, what do we replace? N times 2 plus 1. So every once in a while, you are going to have to kind of do a little guess and check. We tried addition, it didn't quite work. We tried multiplication, it didn't quite work. Can we do a combination of multiplication and addition and see if it works? So that's where it's going to take a little bit of extra. So our expression for this one is n times 2 plus 1. That's our expression. No matter what number you put in for n, you'll always get the right value. So that's a next step up. So the first two, not too bad. This is the next step up. This one we're going to take some time on and spend some time practicing that one. Then we go on to this last example here. Finding a, and I wrote formula and I should have wrote expression. So let's do expression. All right. This is base and height and area. You have 3 things. So now you've got to think about what's the same on every single column or every single row.
The base is 8, 8, 8.
The base is always 8. So you're probably going to have an 8 in your expression. So let's think about this. How do I use my base and my height to get my area? Or maybe you want to use your
Divide by add.
height and your area, or how do we get there? I'm trying to think of some combinations that might work.
Divide and
What do you think?
1 times 4. Oh, wait. 1 was 4 times 2. I don't know.
So, all right, let's try that for all of them. So you've got 1 times 4 times 2. So you took your height times your area times 2. Let's try it on this next one here. So that would be a height of 2 times 8 times 2. Does that equal 8?
No.
No. So that one probably doesn't work. That's okay. But we can guess and check.
Dividing plus.
Dividing and adding. Okay, what do you want to divide?
8 and 4.
Look at what we're trying to solve. We're trying to get to area. So that's our blank one. So we're not really going to want to use the 4, 8, 12, or 16. Aiden, what do you think?
So it's base times height divided by 2.
Okay, let's try that. So let's try the first one. 8 times 1 divided by 2. 8 times 1 is 8 divided by 2. Well, I'm just trying right now. Okay? 8 equals 4. Does that work? Okay, let's try another one. Let's try the third one down here. 8 times 3 divided by 2. What's 8 times 3?
24.
24 divided by 2, and that equals 12? Oh, that seems to work. Okay, so our base is the same every time, right? So in our formula, we can use the number 8. Expression, thank you, Grady. In our expression, 8, and then Aiden said we got to multiply by the height, and because I just have a number and a letter, I can write them like that. And then he said we have to divide by 2.
So base times height and then divided by 2.
Base times height divided by 2 gives you your area for this table. And the base every time is 8, so we put an 8 in there. So there's another way though. Let's see if we can find another way. What's true every time? 8. So see if you can figure it out without using the base. So don't use this. How do you get from height to area every time? You don't have to put an X through yours, but
Oh.
Mason?
Times it by 4.
So Mason says we can go times 4. Does that equal 4?
Yes.
Times 4, does that equal 8?
Yes.
Times 4, that equals 12?
Yes.
Times 4, that equals 16?
Yes.
So another expression that we could use is 4 times what?
4.
H, our H value here. So either one of those. So sometimes there's multiple ways.